In this video, I'm going to describe the Black-Scholes Greeks, which are the partial derivatives of the option price with respect to the variables and parameters of the PDE. Let's start with the Greek we've already discussed in part 1 of this video series, when we derived the Black-Scholes PDE. Remember that when we performed delta hedging on our portfolio, we had to identify a value called delta such that shorting an equivalent amount of the underlying would eliminate the risk coming from variations in the underlying's random fluctuations in price. Thus, delta tells us by how much the option price changes when a change in the underlying price occurs. By shorting a proportional amount delta of the underlying, we are compensating for each increment or decrement in option price by a proportional decrement or increment of the underlying price. By doing this, we are producing a portfolio that doesn't change in total value when the underlying price changes. Another commonly used Greek that can be found in the Black-Scholes PDE is gamma, the sensitivity of delta to the underlying. Remember that one of the assumptions behind the classical Black-Scholes model is that delta hedging is performed continuously, i.e. the delta is continuously recalculated. This is because changes in option price with respect to changes in the underlying price are not linear. Changes in the underlying do not just affect the option price level, but also the rate at which the option price varies. Thus, gamma is a measure of how the rate of change delta varies with change in the underlying. Theta, or the derivative of v with respect to time, is the last Greek that is also found in the PDE. It is a measure of how the option price changes as it approaches expiry, given that all other variables and parameters are constant. And these are the correspondences of the previously mentioned Greeks with the terms of the Black-Scholes PDE. Vega is not found in the PDE and is not quite mathematically correct in the sense that it is the derivative of v with respect to a parameter and not a variable. It is nonetheless a useful concept and is often used in practice. Vega is the sensitivity of the option price with respect to the underlying's volatility. This Greek is particularly useful when doing volatility arbitrage. Speed is the third derivative of v with respect to the underlying price. In other words, it is the sensitivity of gamma to the underlying price. Rho is the sensitivity of the option price to interest rates. In practice, we usually use a whole term structure of interest rates, meaning that the interest rate changes with time. In that case, rho would then be the sensitivity to the level of the rates, assuming a parallel shift in the rates at all times.